Having discussed why macrocytic anemia occurs in deficiency of folic acid, now we are going to discuss that macrocytic anemia also occurs in vitamin B12 or cobalamin deficiency. And it is similar to the anemia seen in folic acid deficiency. Megaloblastic anemia or macrocytic anemia, where large size RBCs, oversized RBCs are present in blood circulation or the precursors thereof in bone marrow. Why does that happen? They are not only similar, they are indistinguishable from each other. Why does that happen? Let us see. For that, we will have to go back to metabolism of role of tetrahydrofolate as a carrier of 1 carbon units, as we discussed, and it carries 1 carbon units in various redox states. For example, it can be methylene, it can be methinyl, it can be methyl, it can be formimino, or it can be formyl, formimino or formyl. So various redox states ka tetrahydrofolate we had discussed is a carrier. Now an important part of this lecture that these various forms are interconvertible. Here you can see interconversion between various forms. So in other words, once a 1 carbon unit is attached to tetrahydrofolate, it can be converted to various other forms also. So there is no difference after that. But there is an exception, and that's a very big exception, and an exception of crucial significance. That is, that this conversion of methylene tetrahydrofolate to methyl tetrahydrofolate, this is irreversible, unlike all other interconversions. Simply stated, once it has been converted to methyl tetrahydrofolate, the reverse reaction is not possible at all. So methyl tetrahydrofolate एक तरह से lock हो गया और it cannot enter the mainstream. Tetrahydrofolate can be relieved, can be retrieved from this methyl tetrahydrofolate only in one way. That is, अगर ये methyl group remove हो जाए, then tetrahydrofolate can be generated. So I am repeating, tetrahydrofolate एक तरह से locked trap की तरह act कर रहा है because of irreversibility of this reaction. So tetrahydrofolate can enter the mainstream only if this methyl group, if it is able to get rid of this methyl group. Now an important point, here comes role of vitamin B12 or the cobalamin. Methyl tetrahydrofolate can transfer its methyl group only to B12. That's the only reaction by which it can get rid of its methyl group. And B12 later on, it transfers the methyl group to homocysteine to form methionine, but that is besides the point. At the moment, only way to get rid of methyl group is to transfer it to B12, और अगर B12 भी deficient है, तब क्या होगा? This deficient या absent, this transfer will not be possible. So methyl tetrahydrofolate will remain as such in this trapped form. In other words, tetrahydrofolate has been now trapped in form of methyl tetrahydrofolate. Because of irreversibility of this reaction, tetrahydrofolate cannot be retrieved, cannot be obtained, and methyl group cannot be eliminated because of deficiency of B12. So in other words, B12 deficiency leads to folic acid deficiency because of this so-called folate trap. This is also called methylfolate trap. All right. So we finish with this. Why macrocytic anemia indistinguishable? Because B12 deficiency leads to folic acid deficiency. Now, one or two important points. As we had discussed last time, that folic acid deficiency is not very common. In fact, folic acid, the name comes from a Greek word folium. That means leaves. So it is present, the folic acid is present in a number of leafy vegetables. So therefore, and its requirement is not very large, so इसकी deficiency बहुत कम होती है, except in alcoholics where intestinal absorption decreases, or in malabsorption syndrome, or in pregnant women, lactating women where the requirement rises. But B12 deficiency is very common, particularly in vegans, the ones taking only non-vegetarian food, because B12 can be synthesized only by mycobacteria. Only only by microorganism, not microbacteria, only by microorganism. So it is present in non-vegetarian food, so non-veg people can take it, can obtain it. But what about vegetarians, vegans, not present in vegetarian food? So that deficiency is much more common compared to folic acid deficiency. In fact, it is very common these days. So as we had seen that its deficiency will lead to folic acid deficiency also. Just a trifle, this has got, cobalamin has got a very complex structure, very complex structure. You people don't know, not even postgraduates, but it contains an important, it contains cobalt. And the only function of this micronutrient cobalt that it is part of vitamin B12. So that's it. And finally, I leave you with a question. B12 and folic acids are not the only vitamins where anemia develops. It also develops in vitamin C deficiency, B6 deficiency, and some more also. Please find out. And one more question, much the same way as megaloblastic anemia of folic acid deficiency and B12 deficiency are indistinguishable. Much the same way, anemia because of iron deficiency and copper deficiency are similar, in fact, indistinguishable from each other. Why? Try to find out the answer. That's all. Thank you so much.